The eye is responsible for your special sense of vision and relies on photoreceptors to accomplish this. There are three coats or layers to the eye, and some of these have specializations. The outermost coat is the sclera. It has a specialized clear area in it called the cornea. The middle layer is the uvea. The ciliary body, the choroid coat, and the iris are all specializations of the uvea. And then the innermost coat is the retina. As we look at this eye model, we have the sclera, which is the tough white outer coating of the eye. And you can see that here in the front, the sclera is clear to allow light to get into the eye. This is the cornea. The choroid coat is the dark middle layer. It's going to have the blood vessel supply. The choroid coat has a specialization called the ciliary body. The muscles in the ciliary body help hold the lens in place and help the lens in focusing. The iris is a specialization of the uvea. It's a muscle that when it contracts, it closes the pupil. This controls how much light enters the eye. The pupil is simply the hole the light goes through. Here you see the lens still in place, but the inner coat of the eye is the retina. The retina is the nerve cells. All of this is a network of nerve fibers that come together to make up the optic nerve. At the area where all of the fibers enter the back of the eye, we have the optic disc. At this point, there are no photoreceptors. This is your blind spot. The eye is divided into two major chambers or spaces. The anterior chamber has aqueous humor in it. Aqueous humor is constantly being formed and reabsorbed. The posterior chamber has a gelatinous-like material in it called the vitreous humor. The vitreous humor is constant. The vitreous humor helps keep the retina pushed against the choroid coat. Since the choroid coat has the blood supply, this is what nourishes the nerves. The sheep's eye here has been cut open. We have over here the anterior view. The lens has been taken out. The preserving process makes the lens not clear. Here is the hole that the light comes through, the pupil, and what we can see through the pupil is the cornea. Then we have the iris and the ciliary muscle. And out here we have the sclera. Over here, here's where the optic nerve goes in, so that's that blind spot. The sclera is the heavy white outer part. The choroid coat is this black part. And then the retina is this fine, filmy part that is just the nerves. Visual acuity is one of the vision tests. Visual acuity uses the Snellen eye chart and helps check to see if the lens can change shape like it should, if the ciliary body is functioning well, and make sure that the eyeball is the right length so that the focal point is not in front of or behind the retina. Another test of vision is to test for astigmatism. The cornea should be nice and smooth. If it has irregularities in it, your vision will be blurred. When you look at the astigmatism chart, if all of the lines appear to be equal, then you do not have an astigmatism. With an astigmatism, some lines would appear darker than others. Colorblindness checks to see if all of your cones work like they're supposed to. Cones are the photoreceptors that pick up color. It's a series of dots with different colors to see if you can see certain objects in them. The near point of accommodation of vision tests for the elasticity of the lens. If you look at something that has fine detail to it, like the point of a pen, and you begin bringing it closer and closer to your eye while staring at it, there will be a point at which you will not be able to see it clearly. For a normal person, this is about 10 centimeters. Infants have almost a round lens. The object can get quite close to them before it's distorted. As we age, our lens loses its elasticity. This is why older people have to hold things far away from them sometimes. This leads to the farsightedness of age, which is called presbyopia. The accommodation pupillary reflex checks to see if your pupils respond appropriately as you move from distant to near vision. When you are looking at things in a distance, your pupils dilate to let light in. As you look at something close up, your pupils constrict. This is because when you look at things close up, your lens has to bulge to focus the light appropriately. When your lens bulges, it gets smaller in diameter. If the pupil did not constrict appropriately, then light might go around the edge of the lens instead of straight through the lens. The ophthalmoscope can be used to look at the retina of the eye. When you look through the ophthalmoscope, you look through the pupil to look at the retina. You should be able to see the optic disc and blood vessels that feed the eye.